So now that we've talked about how to solve one-step equations, we're going to jump in and talk about how do we solve if we have two steps. Two steps meaning two operations. And so I've listed out our steps here, and a couple of these we have already discussed. Number one, always draw that line down the equal sign. So let's get that line drawn. A little bit off to the side there, but it works. We want to make sure that we change all of our subtraction to addition. So we don't have any here, so we're good to go. The next thing we want to ask ourselves is, do we have the distributive property on either side? And we do not. We want to ask ourselves, are there any like terms that we can combine? And in this example, we don't. And so then you can see my little squiggly line. And this is where we're going to start to move. And what we want to do when we move is we want to solve and isolate the variable. So we want the letter all by itself. So I have 2 times x, we can put a dot there, plus 3. And so we need to get rid of the 2 and we need to get rid of the 3. And we're actually going to work backwards of PEMDAS here. So we want to undo our plus 3. The opposite of a positive 3 would be to take away 3 from both sides. And remember, whatever we do to one side, we always want to make sure we do to the other. You'll notice I draw my line, my horizontal line, just to kind of show that I'm subtracting 3 from both sides. And so now what I have left, once I do that, my 3's cancel on the left and all I have is 2x. And 15 minus 3 is 12. And again, our goal is to try to get the x by itself. We want 1x. And again, remember that this is 2 times x. And we know that the inverse of multiplication would be to divide. And a fraction bar means division. So we don't need to do our little line with 2 dots, one above and one below. A fraction bar means divide. So just use a fraction bar. We're going to divide both sides by 2. So that we have x all by itself, and here the answer x is 6. And again, just like our problems on one-step equations, all equations we can check our answer. So let's do the check. And remember, to check, we want to write down the original problem. We want to take what we got for x and plug it in for the x. We want to make sure we use correct order of operations on the left-hand side. So multiply becomes, multiplication is before addition. So we are going to multiply and get 12 plus 3. And does 12 plus 3 equal 15? Yes. Check, it works. So you got the correct answer. And again, I cannot stress enough, you can check every single one of your problems. Let's go ahead and look at 3 more examples before we jump into practice. This would be a huge poster in my room about how we solve these steps. So have these notes close by and make sure you go through all 5 steps. That's it. We have 1/2 a plus 5 equals 18. Again, step 1, let's draw the line down the equal sign. Step 2 is going to be change all subtraction to addition. We don't have any. Step 3 is going to be apply the distributive property. I don't have any. Step 4 is going to be combine any like terms. We don't have any. We got to start moving. And so in order to move here, we want to undo the plus 5 or a positive 5, which we know is a negative 5. Whatever I do to one side, I do to the other. We do this to get rid of our 5 on the left. We are trying to isolate our letter A. We're left with 1/2 A equals 13. And here's an example where I see a fraction in front of my variable. And so this would be a great example to apply the reciprocal. To get a by itself, we can multiply both sides by the reciprocal, because when we multiply by the reciprocal, we get 1. And I'll prove it to you. 2 times 1 is 2. 1 times 2 is 2. And whatever we do to one side, we can't forget to write it on the other. We can change any whole number into a fraction by placing it over 1. And 13 times 2 is 26. 1 times 1 is 1. And if we want to simplify this just to make it look a little nicer, we know that 2 divided by 2 is just a, or 1a. And 26 divided by 1 is just 26. So that is an example of multiplying both sides by the reciprocal. So we can get 1a and a all by itself. Let's go ahead and look at example 3. These down. Here we have a negative t plus 8 equals 3. And again, we want to change all subtraction to addition. Draw my line, sorry. Draw my line, change all subtraction to addition. We don't have any. We do not have the distributive property. We do not have any like terms to combine. We need to start moving. I have a quick question. What number goes in front of a letter if it is not written? That would be the number 1. I would put a number 1 right in front of t. That means negative 1t. And remember, we want t all by itself. So as we start to move here, the opposite of a positive 8 would be a takeaway 8 or a negative 8. Whatever we do to one side, we do to the other. My 8's cancel on the left. I have a negative 1t on the left. Bring it straight down. And I have a 3 minus 8, which is a negative 5. And I hope you are working straight down on your paper, lining things up. What I get written down in notes, you need to have written down, please. And I don't want a negative 1t. I want t by itself. And so negative 1 next to t means multiply. And the inverse would be to divide both sides. And to get a positive 1, remember anything divided by itself is positive 1. So a negative 1 divided by a negative 1 cancels out, and we get t equals 5. So again, we want the variable. We could put a 1t there, but we would just want it a positive 1t all by itself. We have one last example. And this example is going to start out, we've got parentheses in the top. It's x minus 7, close parentheses, but a big fraction bar divided by 3. And this equals a negative 12. Let's go through our steps. Get our line drawn. Let's change all our subtraction to add the opposite. We do not have the distributive property because the number in front of the parentheses is just a positive 1, so it's not going to change anything. We do not have any like terms to combine, so we need to start moving and undoing operations. When you see this big fraction here, the first thing we want to undo is the fraction. And we know that this fraction means division. And the inverse of divide is to multiply. And we want to get rid of that divide 3, so we're going to multiply by 3. And what happens is that fraction cancels out, and we're left with x plus negative 7 on the left. And on the right-hand side, a negative 12 times 3 is a negative 36. And we have one more step to do, and that would be to get the x all by itself, and the inverse of a negative 7 would be to add 7 to both sides. And when you do that, we get x equals a negative 29. Again, I can't stress enough, we could write the original problem. We could plug our answer in for x and use the correct order of operations to see if we did the problem correctly. Go through, don't forget